Ever wondered how Copilot, Claude, or any other AI agent can fix your files, scan your project, create folders, or run commands without getting access or sudo? They feel like they are inside your machine, but they are not. The secret is quite little protocol called MCP, and today we are going to open it up. Hello everyone, welcome to Build and Automate. Today we are going to discuss about MCP. It is not new, but it is becoming extremely important for real world AI agent use cases. It's not a feature, it's a fundamental shift in how AI interacts with reality. A missing link that transforms AI models from smart text predictors into fully capable software agents that can interact with your tools, system, databases, cloud, or even your infrastructure. By the end of this video, you will not only understand how Copilot, Cursor, or Cloud magically access your files, you will also be able to build these capabilities yourself. What is MCP? Model Context Protocol. It is a standard that allows AI models to communicate with real system in structured, secure, and predictable way. It is not a plugin or a wrapper, it's a protocol like HTTPS, but built for AI agent. A protocol that defines how model connects, what model is allowed to do, what tools it can use, what resources it can read, and how results flow back to model. It is the foundation behind modern agentic AI. In short, MCP is an open protocol that gives model controlled access to tools, data, APIs, and real world environments. Why MCP matters? Because large language models are brilliant at reasoning but disconnected from world. Without MCP, LLM is basically saying, I can tell you what to do, but you have to do it. With MCP, the model says, give me access to the right tools and I will do it myself. This is how AI agent edit files, build apps, run command, and whatnot, all without giving model unrestricted system access. MCP gives us power with boundaries. Let's go through the architecture you see here. On the far left, we have MCP client. This is your AI model inside an app or IDE. For example, Copilot in VS Code, Claude Desktop, or a custom agent inside your terminal. The client connects to one or more MCP servers. These are programs you write. Each MCP server exposes two main things: tools and resources. Tools are actions that model can perform. Run a shell command, create a file, query a database, hit an HTTP endpoint. Tools are basically capabilities. Whereas resources, these are data sources model can access. Files, APIs, knowledge bases, config directories. Resources gives a model context. And you see here permission. Permissions defines what tools model is allowed to use, what resources it can read, what scope it's restricted to. These ensures safety, isolation, and control. So the flow is client request MCP servers, MCP server exposes tools and resources with the proper permissions and respond back to client. This is how AI agent interact with your system cleanly, safely, and predictably. Let's understand a single MCP tool call. It begins with the client, usually a AI agent, establishing a connection to a server. Server then respond by advertising all the tools available and resources it has. Once the model understands what's possible, it chooses the appropriate tool based on its reasoning and send the request with required arguments. Tool then executes on host machine, often interacting with resources such as files, APIs, logs, or database. After completing this action, the tool returns a structured JSON result back to the server, which is passed to the client. Client then incorporates this result into its next reasoning step. decide what to do next, and cycle continues. Each participant has a clear role. The client reasons, server exposes capabilities, the tool perform action, resource provide data, and permission keep everything safe. Together, they form a execution loop that powers modern AI agents. Let's see it in action. Now let's look at the simple but powerful MCP setup. An MCP server that exposes file tools. An MCP client that connects OpenAI to those tools. This is the same pattern tools like Copilot, Agent and Claude desktop use under the hood. But here everything is in just two files, server.py and client.py. First let's understand server.py. This server is responsible for exposing tools that AI can use. At the top, we import the MCP server classes, stdio, transport, and a few helpers like path, async.io, and sys. We define a working directory called MCP underscore workspace. This is the sandbox folder where all file operation will happen. If it doesn't exist, we create it. Then we create MCP app equal to server demo server. This names our server demo server. This is how client will identify it. Next, we implement list tools. Whenever client connects, it can ask what tools do you support. Here we return three tools: write file, read file, and list files. Each tool is described with a name, a description, and a JSON schema for the input. That schema tells the model what argument it needs to send. Then we implement call tool. This function receives a tool name and arguments and actually does the work. If the tool is write file, we print lot to stdio. Write the file into MCP workspace and return a simple text response like wrote file name. If it's read file, we open file from MCP workspace and return its contents. And if it is list file, we scan the directory and return the list of files as a new line separated string. All tool outputs are wrapped in text content, which MCP uses to send text result back to the client. Finally, in main, we start the server. We load the server is starting. We opens a stdio connection with stdio server, and then we call app.run to start handling MCP messages. So this entire file is a tiny file system microservice exposed via MCP over stdio. Now let's look at client.py, which connects to OpenAI to this MCP server. At the top, we import client session, stdio server parameters from MCP, stdio client, and OpenAI client. We also read OpenAI API key from the environment. If it is not set, we print error. Inside run demo, we first configure how to start MCP server. This tells client when we start launch Python 3 server.py and connect to it via stdio. Next, we open a stdio client. We initialize MCP session and now client is connected to the server. First thing we do is call session.list tools. We convert the MCP tools into OpenAI tool definition. Each one becomes a function tool with a name, description, and parameters. We then print the available tools so user can see. After that, we show a small prompt. What would you like to do? You can type something natural, like create a file notes.txt with some text. Show me all the files. Read the content of notes.txt. We build a message list, a system telling the model it has file tools and user message with query. Then we enter a loop up to 5 steps. We send the message tool definition to GPT-4o mini model or any other model you want to pick. We get back either a normal assistant message or a message from the tool scroll. If there are no tool call, the model is done and we just print the answer. If there are tool calls, loop through each requested tool, pass the tool name and arguments, call session.call tool with name and argument over MCP. And then we get the result from the server, print it and append it back into the conversation as a tool role message. That gives model feedback like, here's the result of write file. Here's the content of the file you just read. Then loop continues, giving the model a chance to call another tool or to respond to the user. In simple terms, OpenAI model decides what to do. MCP server decides how to do it on your machine. Client.py is the glue that routes tool calls from between them. Let's execute our code. It will start MCP server and it will connect to it, and also it should create MCP workspace folder as soon as client is connected. Here we see MCP workspace folder is created. Now let's ask OpenAI to create a shell script to pull the repo name for a user. So create shell script get repo.sh to pull the name of all repos for a user. It should create a shell script now. We will also validate that shell script created by OpenAI with the help of MCP server. So we have a shell script created. It's a simple short shell script which it has created to pull all the repo name for a particular user. Let's execute this shell script. Here we see all the repo names. Thank you for watching. If you liked the video, please like, share and subscribe. Thank you.